Alright, so today we're gonna do a fun little video, not related to any other classes or anything. It's just, well, you could say it's sort of like, could be related to Calc 2 maybe, but it's just something, just a curiosity. So I'm going to go ahead and look at the sum of the odds. One plus 3, you can see that if I put them together, I get 4, which is a square. Let's say I add 5, and the way I'm going to do it, I'm going to grab 2, I'm going to add them as an L. So 2 and 2, which is what I have on this and this, and one more is 5. If I put them together, they're going to go up here. And that gives me 9, which is another perfect square. And so the idea here is, in this case, n is 1, and I'm writing with this form, by the way. N equals to 1 would correspond to, well, n equals to 0, n equals to 1, n equals to 2, and this is going to be equal to n plus 1 squared. That's what we claim. And one way to see it is by looking at those squares like that. And if you think about it, what you're adding, when n is equal to 2, your 2n would correspond to 1n, 2n's, plus 1 is the corner piece that you're missing to make it into a perfect square. So the question is, how else can we do the addition? Mathematical induction, of course, would say that if you can prove that for n equals to 0, that's where my naturals will start today, the equation holds. Well, you put n equals to 0 is 1, n equals to 0 here is going to be 0 plus 1 squared, 1 equals to 1 holds. Then suffices for you to assume that this holds true and show that it holds for n plus 1. What would it look like, this equation would look like for n plus 1 instead of n? So instead of adding n plus 1, instead of n, terms, you're going to have 2n plus 1. You're going to have n plus 1. So you're going to have n plus 1 here. And that would be 2n plus 3. So we would have to show that this is equal to, we don't know, we have to show that this is equal to plugging here n plus 1. N plus 1 plus 1 is n plus 2 squared. So that's what we would have to hope to show. That when I add up to 2n plus 3, I get n plus 2 squared. Of course, I will have to assume that this one is true. So let's go ahead and see how you do it. Well, I kind of started here. I'm going to go ahead and write my left-hand side. I want to write it as 1 plus 3 plus 5 plus all the way out to 2n plus 1. And I want to add the extra term that we determined was 2n plus 3. And that's going to be equal now. I'm going to assume my induction hypothesis is that this is going to be n plus 1 squared. And I'm going to keep my 2n plus 3. I just substituted in my inductive hypothesis that says that this big sum equals n plus 1 squared. And then at this point, it would be a matter of foiling things out. And you get n squared plus 2n plus 1 plus 2n plus 3. And I factor it out as n squared plus 4n, or collected actually, plus 4. And that now I factor it out as n plus 2. That's almost disappearing. Let me shake this marker. N plus 2, much better, squared. So by using my inductive hypothesis, I can show that that's the case. But is there another way that we can use? Sure, there is. So let's take a look at what's another way to prove that this sum equals n plus 1 squared. So we looked at the squares. We looked at just straight up inductive hypothesis. So let's go ahead and just do a direct proof. So let's take a look at that. Let me erase this and redo it again. Alright, so let's take a look at this one. So the way I'm going to do it, I'm going to write it as the sum of 1 plus 2 plus 3 plus 4 all the way out to 2n plus 1. And then I'm going to subtract 2, 4, 6 all the way out to 2n. And that should be the sum that I have here. Let's call it S. Well, what I can say is that this one is just going to be the sum of 2n plus 1, so 2n plus 2 times 2n plus 1 over 2. I'm using the fact that the sum of the numbers from 1 to n is n plus 1 times n over 2 minus, let's put it here, 2 times the sum of 1 plus 2 plus all the way to n. So this is going to be equal to, let me factor a 2 out of this one, so it's going to be n plus 1, 2n plus 1 over 2 minus 2 times, and this is going to be n times n plus 1 over 2. As you can see, my marker is dying. But in addition to that, the 2's are canceling. And what I obtained here is going to be that I have a common factor n plus 1 on both terms. I have n plus 1 here and n plus 1 here. We'll see if we survive one a little bit more for the video with this marker. It's very pale. Anyway, so it's going to be n plus 1. And then I'm going to have 2n plus 1. That's the term I have here, minus the term left over here is n, minus n, and that gives me n plus 1 times n plus 1, which is precisely what I wanted, which is n plus 1 squared. And just like my energy level today, my marker is dying. Alright, well, we were able to give then 3 different proofs of the fact that adding 1 plus 3 plus all the way to the nth odd would be n plus 1 squared. I hope you enjoyed that, and thank you for watching, and I'll see you in the next one.